Question 5 is question about group 2 elements and their compounds. Explain why the melting point of magnesium is higher than the melting point of sodium. Very classic question, but if you don't know what the key points are, like what the mark scheme wants you to say, you're going to struggle a lot because you're just going to waffle and waffle and waffle, and then you might get 1 out of 2 marks when you could have easily got 2 out of 2 if you just looked at the mark scheme for previous kind of questions like this, or knew what they wanted you to say. So when we know magnesium, well, Mg2 plus has a higher charge than Na plus. Now, as it's got a higher charge, Mg2 plus is smaller. Mg2 plus ions are smaller than Na plus ions. Remember, the greater positive charge, smaller the ion, and more negative the negative ion, the bigger the ion. So Mg2 plus ions are smaller than Na plus ions. What does this mean? Well, a stronger attraction to C of delocalized electrons, hence stronger metallic bonding. That's it. Obviously I did waffle on a bit. All you had to say really was these two key points. Mg2 plus ions has a higher charge than Na plus ions, therefore stronger metallic bonding. But I prefer to show this stronger attraction to C of delocalized electrons, stronger metallic bonding. Mg2 plus ions do have a higher charge than Na plus, therefore Mg2 plus ions are smaller than Na plus ions. And then 5.2, given equation show how magnesium is used as a reducing agent in the extraction of titanium. Classic equation they want you to memorize. It's TiCl4 plus 2Mg arrow 2MgCl2 plus Ti. TiCl4 plus 2Mg arrow 2MgCl2 plus Ti. Explain in terms of oxidation state why magnesium is a reducing agent. If you look at magnesium, we've got magnesium here, oxidation state of 0, single element. And then magnesium here, well, MgCl2, we don't care about the 2 in front of it, the number of moles, we don't care about that. So MgCl2, well, chlorine got -1 charge, it's in group 7, so -1 times by 2 -2. Therefore, magnesium must have a +2 charge. So we've gone from a 0 to +2, and for titanium, well, we've gone from chlorine -1 times by 4 -4 +4 to 0. And now we've got the oxidation states done. Now we can talk about it. So Mg changes oxidation state from 0 to +2. So electrons are lost. Ti changes oxidation state from +4 to 0. So electrons are gained. That's what we have to say. I mean, that's all we have to say, but it's 2 marks and it is a bit of a long explanation. But the equation you need to know off by heart: 2Mg plus TiCl4 arrow 2MgCl2 plus Ti. And then the explanation: to calculate the oxidation states, don't be intimidated by this 2 moles or this 2 moles here. Just ignore it. Basically cross it out. Obviously don't in this equation because it has to be a 2 here. But when you calculate oxidation state, ignore it, and then you're left with Mg and Cl2. Well, Cl2 is group 7, so -1, -1 times 2 -2. Therefore, magnesium must have a +2 to get an overall charge of 0. And that's how you work out. And then 5.3, state was observed when dilute aqueous sodium hydroxide is added to separate solution of magnesium chloride and barium chloride. The observation with magnesium chloride is going to be a slight white precipitate, and the observation with barium chloride was going to be no visible change. And it says in the mark scheme, do not allow nothing or no observation. So very specific with what you want you to say. Don't say nothing or no precipitate, no visible change, no reaction. Or colorless solution. That's also something they like to say. Obviously the no reaction, classic one, but colorless solution as well. You could say colorless solution. So observation with magnesium chloride with dilute aqueous sodium hydroxide, slight white precipitate. Observation barium chloride, no visible change. And that is the end of question 5.